Hello, my young mathematicians. Today we're going to go over another algebraic way for solving linear systems. It is called the elimination method. So, with elimination, the very first thing that we do is we try to see which variable in our linear systems we could eliminate by either adding or subtracting the two equations together. So for example, we have our equation 3x minus 6y equals negative 18 and 4x plus 6y equals 4. If I look at them, I can automatically see that I have a negative 6y and a positive 6y. If I were to add those together, I would get 0 because the negative 6 would cancel out the positive 6. So now that I've seen which variable I could eliminate by adding, I can then continue on. So I add my 6y and my negative 6y, and they eliminate. I then add my x variables, which gives me 7x. And then I add what's on the other side of the equal sign, which is negative 18 plus 4, and that gives me a negative 14. I can then find that my x will equal negative 2. Now that I know that x equals negative 2, I can go back and substitute negative 2 into one of my equations for x. So I'm going to take my second equation, and I'm going to take negative 2. I'm going to substitute it into x and solve for y. So I get 4 times negative 2 plus 6y equals 4. If I simplify it, I get negative 8 plus 6y equals 4, which simplifies further down to 6y equals 12, which gives me y equals 2. Now that I have what my x and my y equals, I can take those points, negative 2 and 2, and I'm going to check them to see if they're a true solution for those linear equations. So I'm going to take negative 2, I'm going to substitute it into the x, and positive 2 into my y for my first equation, and I get 3 times negative 2 minus 6 times 2 equals negative 18, which simplifies to negative 6 minus 12 equals negative 18, which comes out to negative 18 equals negative 18, so those points are a solution for that equation. I then take those 2 points and I input them into my second equation. So I get 4 times negative 2 plus 6 times 2 equals 4, which simplifies to negative 8 plus 12 equals 4, which comes down to 4 equals 4, which is true as well. Thus, negative 2 and 2 is a true solution for those two linear equations. Now, we had two very easy equations to eliminate from, but our equations are not always that simple. For example, 2x minus y equals 4 and 4x plus 2y equals 12 are two equations if you look at, you can't clearly see a variable that could easily eliminate. But that's not a problem. We look at it a little bit closer and we say to ourselves, well, what equation could we multiply by a certain number in order to eliminate a variable? If I look at my equation, I can see that the top equation could be multiplied by negative 2 in order to make the 2x a negative 4x. Once it's a negative 4x, I could then eliminate it with a positive 4x from the other equation. So that is exactly what I'm going to do. I'm going to multiply negative 2 times 2x and negative 2 times negative y and negative 2 times 4. We have to follow the golden rule of math, which is if you do something to one side of the equation, you have to do the same thing to the other side. So when I multiply it by negative 2, I then get negative 4x plus 2y equals negative 8. Now that I have a negative 4x over my 4x over the second equation, I can easily eliminate my x variable. That leaves me with my y variable, which when added together equals 4y. And the other side of my equation, If I add negative x and 12, that will give me a positive 4. Thus, I find that my y equals 1. Now that I have my y, I can input that or substitute it into my other equation. So substituting 1 for y, I get 2x minus 1 equals 4. Solving for x, I get 2x equals 5, which simplified gives me x equals 2.5. Now that I have my 2 points, I'm going to go and check and see if my solution is true. So I take my x point of 2.5, and I'm going to input it into my first equation. And I'm going to take my 1, which is my y coordinate, and input it as well into my first equation. So I get 2 times 2.5 minus 1 equals 4, which simplifies to 5 minus 1 equals 4, which is 4 equals 4. So it's true. I'm going to do the same thing to my second equation. So I'm going to get 4 times 2.5 plus 2 times 1 equals 12, which simplifies to 10 plus 2 equals 12, which shows me that 12 equals 12, which means it's a solution for that equation as well. This means that 2.5 and 1 is a true solution for those two linear equations. So in conclusion, while solving a linear system using the elimination method, we first have to add or subtract the equations to eliminate one of the variables. Once we've eliminated a variable, we can solve for the resulting variable. Once we have found the solution for that variable, we're going to take that number and we're going to input it into one of the other original equations to find the value of the other variable.